And this is NASA Now. The crew of Expedition 27 is well into their first month on board the International Space Station. We'll meet an expert to discuss some of the research the crew will be conducting. That's ahead. First, here's what's happening at NASA Now. More than 300 experiments have been conducted on the International Space Station to date, and NASA says the orbiting lab is an anchor for the future of human space exploration. This video was taken recently by Expedition 27 flight engineer Katie Coleman, flying through the International Space Station with a high-definition video camera. And after 30 years of spaceflight and more than 130 missions, NASA's space shuttle fleet is retiring. They all have new homes. Shuttle Enterprise moves to the Intrepid Sea, Air and Space Museum in New York. Endeavour heads to the California Science Center. Shuttle Discovery will be on display at the Smithsonian National Air and Space Museum in Virginia. And Shuttle Atlantis will move to the Kennedy Space Center Visitors Complex in Florida. Now let's take a look at the past.
Expedition 1 was the first long-duration stay on the International Space Station. The three-person crew stayed aboard the station for 136 days, from November 2000 to March 2001. This was the beginning of an uninterrupted human presence on the station.
One of the areas of continuing research Expedition 27 will be conducting is the effects of microgravity on the human body, biology, physics, and other materials. Here to share some of the findings to date is Assistant Program Scientist for the International Space Station, Camille Alleyne.
The International Space Station is a unique world-class laboratory. It is orbiting the Earth as we speak. It houses 6 astronauts at its full complement. To give you a sense of how big it is as big as a US football field, including the end zones. The International Space Station is so important because it is the most engineering, technologically advanced achievement of our time. It has taken 10 years to construct, and we have been able to demonstrate very complex operations and assembly of huge structures in microgravity and space environment. We know microgravity, or the absence of gravity, has an adverse effect on the human physiology or the human body in areas of bone density loss, the atrophying of muscles. It affects your balance. It also decreases your immunity or your immune functions. And so one of the experiments that have been conducted on the International Space Station is looking at nutrition, or the diet of the astronaut, and how that could be used as a countermeasure for those adverse effects. How boiling works on Earth is that the water molecules nearest to the heat source or the fire expands. As it's getting hot, it expands, and we know that hot air rises, so it rises to the top and it exchanges space with the cold water molecules that fall to the bottom. We call this process natural convection, and that occurs because there's buoyancy here on Earth. Well, in microgravity, there's no buoyancy. So when you're boiling water, the bubbles or the water molecules nearest to the heat source expands, and it keeps expanding, but it doesn't rise. And so each of the bubbles are being absorbed by the bigger bubbles, and it's trapping heat. And so you would think that it's not an efficient way for the transfer of heat. But scientists are very, very interested in this phenomena because it can really help in building more effective cooling systems here on Earth. The best part of my job is the fact that my job represents who I am and what I am passionate about. I am committed to communicating to the global community the benefits of space and the benefits of space exploration. I am also very committed to educating and inspiring young people to pursue careers in engineering, math, science, and technology. I would really like them to gain a love for science and math, and my job allows me to do that.
Did you know that when the International Space Station is completed, it will weigh around 925,000 pounds, or approximately 419,000 kilograms? That's the approximate weight of 320 automobiles. Well, now you know.
Now it's time to check out what's up.
This is a view from inside the cupola of the International Space Station. An Expedition 27 crew member snapped this image, in which you can see a low-pressure system in the eastern part of the North Pacific.
Teachers, now your students can get a sense of planning a trip to the ultimate destination.
Your students can explore the moon, the human presence on the moon, and future exploration by using the Lunar Nautics content module entitled Designing a Mission to Live and Work on the Moon. Check out the NASA Explorer School's virtual campus for these great activities.
Well, that's it for NASA Now. Be sure to tune in next week when we explore the future excavation of Mars. We'll see you then on NASA Now.
NASA Now comes to you from the virtual campus at NASA Explorer Schools.